Hi, this is Leetcode question, minimum size subarray in infinite array. This is the third question of weekly contest number 365. To solve this question, the first thing we will do is find the sum of all elements in the array. So sum equal 1 plus 1 plus 1 plus 2 plus 3, and this equal 8. Now the target equal 20, target equal 20, and this equal to 20 divided by 8 multiplied by 8 itself. 8 is the sum, plus 20 mod 8. 20 divided by 8 is 2 multiplied by 8 plus 20 mod 8 is 4. So that means to cover the whole 20 we need 2 full arrays, because 8 is the sum of all elements in the array. That means we need 2 full arrays plus the smallest subarray with sum equal to 4. Now 2 full arrays, what is the length of them? Is 2 multiplied by the length of the array is 1, 2, 3, 4, 5. So n equal 5. 2 multiplied by 5, and let's say the smallest subarray with sum equal 4 is 2. So the final answer will be 2 full arrays of length 5 plus 2 to cover the 4, and this equal 12. Now for 4, to find the smallest subarray with sum equal 4, the array is 1, 1, 1, 2, 3, and we can repeat it 1, 1, 1, 2, 3. Now the smallest subarray with sum equal 4 is this one, 3 and 1. The sum of these is 4. Now we need 2 full arrays of length 5. So here we have 2, 1, 1, 1, and we need 3. So this is the first full array, and we can repeat it because we have infinite array. So this is why the solution work. This will be the smallest subarray with sum equal to 20. 2 full arrays plus this smallest subarray of length of sum equal to 4. The length of this one is 2, the length of this one is 5, and this one is 5, so the answer is 12. Now the question is, how can we find this smallest or the shortest subarray with sum equal 4? To do that, let's look into the code. So here, as we said, we create the we calculate the sum of all elements in the array. Then we divide target by sum, and we multiply it by n. N is the length of the array. We said here 20 divided by 8 is 2. The length of the array is 5, so this is 10. So initially the answer is 10. Now if this is 0, we don't need to do anything, we just return the answer. Otherwise we need to search for the smallest subarray with this sum, and to do that we need 2 pointers, right and left, and we'll use these 2 pointers to as sliding window to find this subarray. And we need to consider that we can repeat the array infinite number of times, so 1 1 2 3. In this case, because 4 is smaller than the sum of the whole elements of the array, we need only to repeat it twice, 1 1 1 2 3. So left L is the pointer to the left of the window, and right also is the pointer to the right of the window. Initially both of them points to the first element in the array, and we calculate the sum of the sliding window. If the sum equal to the sum we are looking for, which is 4, then we update the length. If it's less than the length of the window is right minus left plus 1. So s initially equal to 0. We iterate until right is less than 2 multiplied by n. N is 5, which is the length of the original array, and in this case n equal to 10. This is why we here we repeated the array only once, so the length of this is 10. S plus equal nums of R model n. Why we do R model n? Because we don't actually want to expand the array itself. What we will do is reuse the array itself. So when we arrive, for example, this is the last element. Now R plus plus, we can put it back to here as if it's here, because this element is the same as this one is the same as this one. Now sum plus equal nums of or S plus equal nums of R model n, then S equal 1, while S greater than sum, S is less than sum, so we break this loop. S is not equal to sum, so we just move the right pointer. So right pointer is now here. Now the next iteration, S plus equal nums of R, which is 1, 2. S is less than sum, so this condition doesn't apply, and then we move the right pointer. Then S is 3, and still it's less than 4, then we move the right pointer here. S plus 2 is 5, 3 plus 2 is 5. Now 5 is greater than sum, so here we iterate. We need to move the left pointer until the sum is less than or equal to or S less than or equal to sum. S minus equal left, which is 1, so here we have 4, and we move the left pointer, so it's point to this one. Is S greater than sum? No, it's 4, so we break the loop and S equals sum. In this case we update the len to take the minimum of the width of the window, which is R minus L plus 1. In this case we have 1 2 3 elements, so len equal 3 because 3 is less than int max, and that's as you can see, this window is 1 plus 1 plus 2, which has the sum equal to 4. Then we move the right, so r is here, 3. We increase the sum is 7, and so on. And at the end you will take the minimum. You find this one as the smallest subarray with sum equal to 4, and this has length equal to 2. So len at the end will be 2, and we return the answer, which is 10 plus 2. And this is the final answer. What if we couldn't find subarray that has sum equal to 4? In that case, the len will be int max, and we return -1.